Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. More formula manipulation. The volume of a cylinder is given by V is equal to pi r squared h. Find the radius r in terms of V and h. Okay. Let's start with the formula. V is equal to pi r squared h. So it's r I want it in terms of, okay? So I need to strip away everything from around r so that I have r on its own, okay? Because down here, down the bottom, I would like to be in a position that I have equals r. Okay, so when you have letters like this written beside each other with no sign in between them, that means they're multiplied. Okay, so to have them cancel, you do the opposite. So the opposite of multiply is divide. So if I divide that by pi h, okay, why am I doing that? Because I want the pi's, oh, sorry, I didn't mean that one. I want the pi's gone off that side and I want the h's gone off that side. Okay, that's why I'm doing it. What I do to one side, I must also do to the other. Okay, so let's cancel them. We have then V over pi h being equal to r squared. Okay, and again, it's always about opposites when you're doing formula manipulation. The opposite of squared is square root. Okay, so the theory is if I get the square root of that, the square and the square root will cancel. What I do to one side, I must do to the other. So that I end up getting the square root of V over pi h being equal to r that radius. And that's my answer for part A. Find the radius r in terms of any other letters, okay? Which means r equals. And like I said on the last one, perfectly okay if you have root v over pi h being equal to r. It's equally correct to write r is equal to root v over pi h. Okay, let's have a look at part B. The curved surface area is equal to A is equal to 2 pi r h. And again, find the radius r in terms of A and h, okay? So just like before, these are all connected by multiplication. When you have all these letters butted up against each other with no sign in between them, that means multiply. And whether that's numbers or whether that's letters, that means multiply, okay? I'm dividing by 2 and the pi and the h. And you can see that's going to leave just my r for me when I do that. Okay, what I do to one side, I do to the other. Okay, so that I get, I'm going to write it the other way just for something different, r being equal to 2 pi h. Okay, and that's part B. There was no squared in that one, so it was actually easier than part A. But the same method. And how you lay out your work, I think, for formula manipulation is really important. So you can see, and I'm doing maths for years, you will visually see me doing to one side what I do to the other. You'll see me cancelling. You'll see me putting in the square root sign. Okay. All that's useful for you to follow your work. It's also useful for when you sit your Leaving Cert and your corrector is correcting it, they can see your steps, okay? They can see that you somehow know what you're doing, and therefore if you make a mistake like all of us humans do, they can go, no, you understood what you were doing. It's just what's called a slip. Okay. Hence, show that a squared is equal to 4 pi hv. Okay. Right, let's see if we can figure out this one. Okay, and this is what I kind of call it an abstracty one, where you're taking a cue from here. It says hence, right? Which implies that I use definitely part B and most likely part A in my answer. So I'm looking at my answer to part A. I'm looking at my answer to part B. And now I'm going, right, these are supposed to be somehow able to give me a squared is equal to 4 pi hv. Okay, now right at this moment, I haven't practiced the sum. I can't see that answer jumping out from these two, only that I have an a here, okay, and I have a square root sign here. So somehow squaring will give me an a squared here, and it'll also get rid of the square root sign here. Okay, so another trick is when they have an hence, and you have two formulas, the root of v, square root of v over pi h being equal to r, and a over 2 pi h being equal to r. Well, the only way that that can equal r and that can equal r is if these two things are the same. Okay, the only way the two of these can be equal to r is if these two are the same. Okay, so let's write down r is equal to the square root of a over pi h, which is also equal to, sorry, I wrote a instead of v, I have a on the brain now, v over pi h, and that's also equal to a over 2 pi h. Okay, so that's what r is equal to. Okay, so I'm just going to concentrate on this bit because there's no r in my answer. Have a look here. Okay, so I'm going to drop this r equals to bit. I'm going to concentrate on these two. Let's square both sides because again we've no square root in the answer. So I'd like to square that side and square that side. Okay, so what does that give me? Well, that will give me v over pi h being equal to, and the rules of indices. If I can just show you that, you may not have that chapter done yet. Let me just find it. There is a page in your log tables, page 21, which is the rules of indices. Okay, and you can see down here, okay, that if I have something in a bracket to be squared, you square the top and you square the bottom. Okay, so that's what I'm going to do over here, and this is going to be a squared, and the bottom is going to be 2 pi h squared. So each of these little pieces have to be squared. So 2 squared, and again, why? It's this rule here. Okay, when you have more than one term in a bracket all to be squared, can you see each term gets squared in our case, but gets the power gets applied to each term. Okay, so now I'm using that rule of indices. So 2 squared is 4, pi squared is pi squared, h squared is h squared. Okay, I hope that makes sense to you. Now, you're looking at this and you're always looking at this, okay? And you're going, well, how do I change him around to make him look like this? Well, I see a squared is on its own. So let's leave a squared on its own there. And so it's this piece we need to get rid of. That's on the bottom. So how we get rid of that is multiply it by it or put it on the top, okay? And what I do to one side, I have to do to the other. Okay, so that you get the 4 and the 4 cancelling, and it'll always cancel when one's on the bottom and one's on the top. Okay, so now that has nicely left my a squared over here. What have I on the left? Well, I have a 4, I have a pi squared, I have a h squared, I have a v, and on the bottom I have a pi and a h. Okay, just like we did here on the right, let's cancel any letters. So the pi will cancel with one of those pi's. Pi squared is pi by pi, okay? So when I'm cancelling a squared, I just cancel out the squared and it'll leave one pi. In the same way, I'll cancel this h and then the square part. Okay, so that I'm left with 4 pi hv being equal to a squared. Okay, so not the easiest to see how to do this. Okay, it does come with a bit of practice, and this idea that if you have two formulas equal to the one letter, you can let the answers equal each other like we did here. So practice that one, see how you get on. If you've enjoyed this video, then why not join us in IT Sligo and use Maths in Practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.